Thank you for coming. I'm going to talk about maximizing GPU efficiency with continuous profiling for GPUs. So what is profiling? Profiling is pretty much as old as programming. I think it was like first done in like the 1970s. I think some IBM folks were trying to figure out what was happening on their computers back then. So it's been around basically forever in computer science. And what are we doing with profiling? We are profiling basically anything that we can to inform our view of the world. We want to see like the memory or CPU and GPU time spent. We want to see the usage of the individual instructions and the frequency and duration of these function calls. So yeah, a lot of different approaches to profiling, but yeah, it's generally speaking super important to performance engineering. So why would we do this? Obviously to improve performance, and then also we can save money. So if we improve our software by like 10%, we might be able to just like turn off 10% of our like servers and save a bunch of money, right? So that would be great. And there are two different kinds of profiling typically that we're seeing these days. So one is tracing profiling, and that is you record each and every event all the time constantly. But obviously that's great for like getting like the best possible view onto the system, but it's like pretty high cost and generates a lot of data. So it's like hard to do continuously. And that is why we're doing sampled profiling. So what we do is basically we sample for a certain duration, like 10 seconds, and we only sample 100 times per second or like 20 times per second, etc. You can tweak that. How often do you want to profile and sample? So like 100 times per second isn't that much for a CPU, and that's why you get like less than like a % overhead on the CPU and like only like 4 megabytes of overhead for the memory profiling. You will most definitely miss things, but if you do it always on, you will eventually see most of the relevant things, right? Like one stack that executed once isn't like relevant to us anyway. Like we want to see the big picture. So yeah, this is basically what we're doing. We see like the stacks on the left-hand side executing, and these are like the functions that are calling each other, and we are just like 20 times per second or 100 times per second taking note on what exact stack we're seeing on the CPU or which stack is like allocating, etc. Yeah, and that allows us to like do it always on, do it in production. Your machine is not the production environment, so it is pretty important to be able to do this in production and actually see what's happening out there in the real world, and do it with low overhead. And we are actually using Linux eBPF, and because we're using something that the kernel is doing, we don't even have to change any of your applications. That means you start one thing and it will start profiling all of your applications, so you don't really have to instrument. Quickly about me, I'm Matthias Loibl, flew in from Berlin, Germany, and I'm the director of Paula Signals Cloud, and I'm also a maintainer of Prometheus, Prometheus Operator. Parka is the open source version of all of what I'm talking about today, and some other projects. So we are basically here for like GPUs, right? And we just earlier this year, after like working on CPU and memory profiling for the last 3 or 4 years, started a preview on GPU profiling. So I'm going to talk about this today and why we think it's pretty great. As you can see in this screenshot, we're talking to NVIDIA and VML to get these metrics out of your GPU. So we can see in the blue line on top, we can see the overall utilization of the node. And then the orange line is one particular process on that GPU. So we can see over here we can see the process ID. So we see individual processes, but we also see the overall nodes utilization, further down the memory utilization and the clock speed, etc. And that will kind of inform where we want to look at the performance of our system, right? So sometimes we can see the utilization drop down, and that might be something that we want to investigate to really make sure that we are using our GPUs to the fullest. Just a couple of more metrics we are collecting. So there's like the power utilization, and the dashed line is the power limit, and then the temperature. Temperature sometimes is important because like eventually if you're like always at like 80 degrees Celsius, you're gonna get throttled by the GPU quite significantly. And then obviously PCIe throughput is interesting. Are you bound by the data you are transferring between CPU and GPU? Perfect. Yeah, so just to repeat, like the negative one is receiving, whereas the positive ones are sending 10 megabytes per second through PCIe. And then we can use all of those metrics to correlate from the CPU from the GPU metrics to the CPU profiles that we're storing. So we're like collecting, like we have done the last 3 or 4 years, using eBPF, those CPU stacks. And we want to like see what is happening on the CPU. So in this case, we might want to look at a particular stack on CPU 0 right before the end because there was some activity, for example. So we can drag and drop and select a particular time range, and then we are presented with a flame chart. And in the flame charts, we can see what the CPU is doing while the GPU is not fully utilized. So in this case, we can see that Python is actually calling eventually the CUDA functions further down. But oftentimes you will see that like the CPU is pretty actively trying to load data and being busy that way and not keeping the GPU busy. If you are using Python, we can see it. If you're using Rust to integrate with CUDA, for example, that also works, but any compiled language is going to show up in those stack traces, and even some of the interpreted languages are going to show up, like Ruby, Python, JVM, etc. So while there's a focus at this conference that we're talking about GPUs here, it really works with like any language and any application. So web servers, databases, and vector databases, for example, also are interested in improving their performance, obviously. Something super exciting that we first introduced this morning, so this is like super fresh and hot off the press, is GPU time profiling. So as you heard, like I was talking about like these GPU profiles, and we look how much time is spent on individual functions on the CPU, but we are like more interested in GPU time spent by these functions. So here's like a small example of CUDA functions, and basically what we do is we tell the Linux kernel to whenever there's a CUDA stack getting put on the CPU, to tell us the start time of that function, and then eventually tell us the time when that kernel terminates, and then we know the duration of how much time that particular kernel was spending on the GPU. And that's super interesting, obviously, because now we can actually see how much GPU time these individual functions are taking on the GPU. And here's a bit more of a real-world example. So at the top, we can see on the right-hand side, we can see like the main function in Python, and then calling down into libcuda down here. And the width of these stacks that we're seeing is like the actual time that we had these functions take up in the GPU.
So this is showing CPU and GPU?
Yeah, so this is like basically the stack on the CPU down to here, and then the leaf of each stack is the function that was taking time on the GPU.
Okay, so what do the colors mean?
The colors are different binaries in this case that are running on your machine. So that's why like blue up here, for example, is Python, and then there's like some I think CUDA down here. Yeah, great question. How do you get started? Because we run on Linux using eBPF, you have a binary that you can run using systemd or Docker works as well. But we also have a daemon set for Kubernetes, and you deploy that. You get the manifest YAML and give it a token. And then some of our customers are already using it for CPU and memory profiling, and they're starting to also integrate their platforms with our GPU profiling, especially like Turbo Puffer are interested in improving their performance of their vector engine, right? And that's really it. Please visit our booth. You get the first 10 people get like to sign up for a consultation, get 2 hours for free if you want to, and we can also do discounts for seed and Series A startups. And that's really it. Thank you so much.